Hello and welcome. So, a certain ellipse has a vertex point at 3, 3 and a covertex at 6, negative 1. What is the coordinate point of the center? Well, first off, you got to know a little bit about ellipses to make this work. So, first off, for any ellipse, you have a center point, right? And then you have either a vertically oriented ellipse or you have a horizontally oriented ellipse. Horizontal oriented ellipse. That's so bad. We'll just shift the center. It's fine. Okay, so one of these two cases. Now, depending on the orientation will depend on the placement of your vertex and covertex points, right? So vertices are furthest away from the center, so that would be a vertex, and then we would have covertex points on the sides. Versus if it's horizontal, that means your furthest points are going to be on the sides. Those are your vertex points. And then up and down are your covertex points. So we got to figure out from the information we're given what orientation do we have, and that'll help a little bit with the center. Okay. So first off, we have a vertex at 3, 3. All right. So vaguely we have 3 over 3 and up 3. Ta-da! Okay, and then over at 6, 4, 5, 6, comma, negative 1, we have a covertex point. Now we know that at some way, shape, or form of your ellipse, you're going to have that being connected, right? Vertex and covertex will be connected. So we have like a fourth of our ellipse here. So looking at this, you'd say, all right, well, we know that regardless of whether we have a vertical or horizontal ellipse, we know that it's going to be covertex is going to be connecting that way, or it's going to connect this way to find where you need to go, right? And that's exactly what we have, right? Or either a center is going to be over here or it's going to be over there. Now, how do you know which one's which? And that is where knowing the difference between vertex and covertex is going to be your best buddy. Okay, we know that the vertex point is the 3, 3. This is your vertex, this is your covertex, meaning that you see how this distance right here is longer than this distance to your vertex? That violates definitions, right? We know that the vertex has to be furthest away from the center, which means it would have to be that point, that distance right there, which means that this can't possibly be your center, and we are looking at right there as our center point, because that has to be the longest distance to vertex, shorter distance to covertex. Okay, and then right there, bam, we just drew it. We now know where that is. So that's at 3, negative 1 is our center point. Finished. Not too shabby. Really is the main thing is graphing it and knowing the definitions, the change between a vertical versus horizontal ellipse there. Thanks so much for watching.